Hi everyone, welcome to my YouTube channel Enjoy Learning Computer Science. To watch the previous videos, watch my YouTube channel. To get notified for my new videos, subscribe to my YouTube channel Enjoy Learning Computer Science. This video is part 3 of computer networks. By now you know the significance of networks. One major purpose and use of networks is the sharing or transfer of data and information. Do you know how data are transmitted across networks? Well, for this only we are using switching techniques. Okay, so switching techniques are used for transferring data across the network. So when the computers are connected through network to transfer data, there will be many paths will be available. So the switching in computer network will help to decide which route is best for data transmission when there are multiple paths available in a larger network. Okay, so when the computers are connected in a larger network to communicate data from one system to another system, many routes will be available. The switching in computer network helps in deciding the best route for data transmission when there are multiple paths in a larger network. Okay, so switching techniques are used for transferring data across network. Informations may be switched as it travels through various communication channels. There are different types of communication channels that we'll study. Okay, so switching in computer network helps in deciding the best route for data transmission if there are multiple paths in a larger network. Now we'll study the types of switching techniques. There are three types of switching techniques: circuit switching, packet switching, message switching. Let's see all these types of switching techniques in detail. The first one is circuit switching. So in this technique, first the complete physical connection between two computers will be established. Suppose if there are 100 systems in a network, if you want to send information from system number 7 to system number 29, 7 to 29, what will happen? The first step to establish a dedicated path between the sender and the user. Dedicated path means a complete physical connection. Okay, so a connection will be established from system number 9 to 27. So but from the sender and the user, that is the first step. So a dedicated path is established between the sender and the user. Okay, so what is the first step? Complete physical connection between two computers is established, and the next one, the data are transmitted from the source computer to the destination computer once the connection is established. So first establish the connection, then data transfer. So when a computer, for example, when a computer places a telephone call, the switching equipment within the telephone system first will seek for a physical copper path all the way from the sender telephone to the receiver's telephone. Now, the important property of the switching technique is to set up an end-to-end path connection between the sender and the receiver. Okay, so the circuit switching, first it will create a connection between the sender and the user. Then the second step, it will transfer the data. After transferring the data, it will disconnect the connection which is created for transferring data. These are the three phases in circuit switching. So what are the three phases in circuit switching? Is connection establishment, then data transfer, then connection disconnection. Now, I have given in detail. First, the complete physical connection between two computers is established, and then the data are transmitted from the source computer to the destination. Okay, so the circuit will be terminated when the connection is closed. Okay. Now in circuit switching, resources remain allocated during the full length of a communication after a circuit is established and until the circuit is terminated and the allocated resources are switched. Once everything is completed, till that all the resources will be allocated for those systems. Okay, that is known as circuit system. So in what are the three phases? Connection establishment, data transfer, connection disconnection. Till it gets disconnected, all the resources will remain allocated for the systems. The next one is packet switching. Okay, so packet switching, listen. So the internet is an example for a packet switched network. Okay, first what will happen, the message, if you want to send messages from one system to another system, the messages will be broken into individual chunks called packets. So the whole message will be divided into small groups, that is known as packets. Okay, so the message is broken into individual chunks called packets. Then after dividing into packets, each packet is sent individually. Okay, each packet will be sent individually. Then every packet will have the source and destination IP address with a sequence number. So every packet will have a sequence number as well as the source and the destination IP address. Why do we need sequence number? Because the whole message we are dividing into packets. So every packet should have a sequence number. So when it receives in the receiver, it has to be arranged in proper sequence. Okay, so sequence number will help the receiver to reorder the packets, to arrange the packets in proper order, then detect the missing packets and send acknowledgements. Okay, so what is packet switching? The message will be broken into individual chunks called packets. Then each packet is sent individually. Now every packet will have source and destination IP address with a sequence number. The sequence numbers will help the receiver to reorder the packets, to detect the missing packets and to send acknowledgements. Okay, so packet switching introduces the idea of cutting data at the source. Entire message is broken in smaller pieces called packets, which are transmitted over a network without any resource being allocated. So after transferring, each packet is transmitted and each packet may follow any route available, and at destination, packets may reach in any order. So you are dividing the message and sending it to any way. So at the destination, all the packets will reach in any random order. So how to arrange this? The packets will be arranged according to the sequence number which is available in the packet. So at the destination, when all the packets are received, they are merged to form the original message. In packet switching, all the packets of fixed size are stored in main memory. Okay. So the next one is message switching. So message switching will use store and forward mechanism. So like packet switching, here also the messages will be broken into chunks. Okay, so there we used a packet system. Here the packet will not be used. This messages will be divided into chunks and it will be sent to an intermediary node. There will be a node in between. So that node will receive all the messages which are divided into pieces, and that intermediate node will arrange all the message in proper order. Then it will send to the receiver's node. Okay, so message is transferred as a complete unit and forwarded using store and forward mechanism using the intermediary node. Okay, and it is not, this message switching is not suitable for real-time applications. Okay, so in message switching, data is first stored by one node, then forward to another node to transfer the data to another system. In message switching, there is no upper bound on size of packets, whereas in packet switching, each packet should be of fixed size, but message switching, there is no upper bound. In packet switching, data packets are stored in main memory, right? Whereas in message switching, the data message is stored in hard disk, which makes it reducing the access time. So message switching use this technique store and forward mechanism. There will be an intermediary node which will receive all the broken messages from the sender, and it will reorder the message and it will send to the receiver. So which is known as message switching. Message switching is not suitable for real-time applications.